Okay, then. I've got a full marker here.
Oh no.
Yeah, I know. It looks pretty...
Is that a square with some circles in it?
Yeah, it's a square which is shaded, which have
Right.
4 circles in, which aren't shaded.
Jack, is this a question about area?
Yes. Yeah, it's work out the area of the shaded section.
Now,
Yeah,
there with the diagram, they're all the same size, those circles, aren't they?
Yeah, they are. And
now,
then 12
tell me the explicit information, the stuff that's actually in your face on the page there, Jack. What does it tell you?
12 centimetres is the length on the top.
12 centimetres?
Yeah, along there, yeah.
Square?
Yes, it is, yeah.
How do you know that?
Because it looks like a square.
Does it not say so?
Oh, yeah, it does. Just fit inside a square. That's true.
So how do you know? It says so.
So, yeah. It's not drawn accurately.
Well, that's okay, because nor is mine.
No, yeah.
That's just a rough sketch. So that 12 as well then, because it's a square.
Yeah, all the sides would be 12.
Do you know how to work out the area of the square?
Yeah, so it'd be 12 times 12.
So it'd be length times length, won't it?
Yeah.
Well, the width is the same in a square, isn't it?
Yes, yeah.
The length, yep. So that's why I'm writing down L squared for the formula. So then when I work that out, everywhere I see the length, I write down...
12 centimetres.
No, I'm just going to make it a math statement.
Okay.
I'm going to write down just the number 12.
Just the number, okay.
12 squared. And so the area of the square, Jack, just as a number would be
144.
Yeah. So if I want to put down the real life statement now, then the area of the square would be 144 centimetres squared.
Squared. Yeah.
And I would this down here, Jack, because I'm making that now be a real life statement.
Real life statement. And then, but how do you have?
But hang on a sec. Hang on a sec. This bit here.
Yeah.
This bit here is just a math statement.
Yeah. Math.
Okay. So the bit in the math statement, the bit on the end with the context, centimetre squared, that's the math statement. So it works out the area of the square. Now, I'd like to pretend something. Get a pair of scissors out.
Yeah.
And chop those circles out.
Yeah.
And when you cut them out of the square, what you're left with? The shaded bit, isn't it?
Yeah, the shaded bit in between. Yes, that's it.
Right.
Yeah.
So come on, Jack. What do you now have to work out then to figure out the shaded region?
The area inside, you know.
Yeah, and what have you got there?
For
what your side that you're going to cut out?
The
four. Now, we'd better try and remember what the area of a circle. Do you know that? Area of a circle.
Oh God.
Is that a yes/no answer? Do you know the area?
No.
No, right. It's this. It's pi r squared.
Yeah, that's
What's
it.
The area of a circle?
Yeah.
What's the area of a circle?
Pi times r squared.
Pi r squared. Yes. Okay.
Pi r squared.
So I'll tell you what we better figure out here. Then we better figure out the radius of each circle. Then.
Yeah.
What I'm going to add something to my diagram. I'm going to add this line from here to here.
Yeah.
Oh, hang on. Isn't that then the same distance from there to there?
Yeah.
Hang on this circle as well, from there to there. And from here to here.
Yeah. Yes, the same.
Yeah, and they're all the same because each one's a radius, isn't it?
Yeah.
If that's the radius, that's the radius, that's the radius. They're all the same length, aren't they?
Yeah.
And what's the total of those?
12.
Yes.
Yeah, 12 centimetres.
In that case then, Jack, if 4 radii is worth 12 centimetres, what's 1 radius worth?
4. 2.
Test it. Not a bad idea. Let's test it. 4, add 4,
4,
add
4, add 4, 4.
add. That's 16, isn't it?
16.
Whilst 4 is a good idea, it's a bit too big, isn't it? Because it doesn't make 12.
It's 3. 3. 3.
So, you know, you said 4. Try it.
Yeah.
Idea. Try it.
Yeah.
Now it's too big. So you've adjusted it. Try it. 3.
3, 6, 9, 12. So it's 12 radius. Okay.
So the radius, each radius is then
3 centimeters.
right. So what's the area of the circle going to be then?
3.
Pi times.
Yeah.
squared.
Pi. Yeah. Yeah.
Radius
And
is
it's
3, isn't it?
oh,
Centimeter.
it's not calculated. Yeah.
Right.
3 squared.
So that
It's not
then
calculated
means.
either.
Well, what is 3 squared?
3 times 3.
Yeah. And what's that value?
9.
So it'd be pi times 9, won't it?
5 times 9. How would you do that? Not.
See, I've done the 3 squared.
Yeah.
Okay.
How
Good.
would you?
Right.
that not-
Just go with that for the moment. You okay with that?
Yeah. Yeah. I've got that
Now,
down.
Jack, normally where you write it is you can write it with the number first and then pi second. Because you know,
Okay.
when you're timesing,
Yeah.
2 times 3 is the same as 3 times 2.
Yes. Yeah. Yeah.
So timesing is commutative. You can put the digits any way around you like. And it just so happens in the maths, we write the numbers first.
Okay.
It's convention. It's what we do.
9 pi.
You don't have to fuss over it too much. They just write the number first. So the area of that is 9 pi.
Of the
How many,
shaded.
how many circles is that?
4.
That's 4, is it? Hang on.
Oh no. Yeah. There's 2 there. Yeah.
Hang on. So if we've got that radius there, isn't that the area of 1 circle?
2. Oh, is it 1? Yeah.
It's just like this. My radius is 3. It's just that circle there, isn't it?
Oh yes. No. Yeah.
You
Yeah.
with me?
Yeah. Yeah. So then it's 9.
But how
And
many of
add
those
another
circles do
3.
you have?
We only have 1 at the moment. We need to put another 3 on.
So how many circles in total?
4.
4. So the total area of the circles
Yeah.
is going to be 9 pi times 4, isn't it?
4. Yeah. 9 pi times 4.
And what would that be? What's 9 times pi times 4? Well, what's 9 times 4?
36.
That would be 36 pi.
Yeah. Yeah.
Okay? So what we do in those circles in the problem, aren't we going to cut those away?
So we need to do 144 take away 36.
Not 36.
Is it not? Well, yeah. Didn't we find what was the area of the whole thing? 144. Surely it's
Take away what?
36 pi.
36
Yeah.
pi.
Pi. 144 take away 36 pi, which
Now,
is
you know in the hang on, do you know in the question, does it say leave your answer in terms of pi? Or
give your answer.
it's
Yes.
paper?
Give your answer in terms of pi.
Right, so if you think back to when we've done this work before, this is a term here,
Yeah.
separated by the subtraction symbol, and this is a term here. But
Yeah.
the term is 36 of those things called pi. So that's
Yeah.
in terms of pi.
Pi.
That's what
So
it
that's
means.
okay.
So that's your answer.
So-
How do I now want to write, you know, on the answer space, is it left centimetre squared or is it blank?
Yes. Centimeter squared.
So you're then going to have, and I write it on here because I haven't got it on the page, but centimetre squares.
So it's
Centimetre
so that's the answer. 144 take away 36 pi centimeter squared.
Yeah, how many terms are there here? 1, 2. There are 2 terms, aren't there? A term here and a term here. And this term is actually some pi, isn't it? 36 pi.
Yeah.
It's in terms of pi.
Right.
That's what that language means.
I thought you'd take away 36 from 144 and that would be the answer.
Ah, well, then in that case, is this 144 pi here?
No.
So this is a different thing from this.
Yes.
This is 144 units.
Yeah, units. Yeah.
This is 36
Pi.
pi. So this thing is a term to do with pi.
Yeah.
It's a term to do with numbers.
Numbers. Yeah.
Different denominations.
Okay.
They're
Brilliant.
different things that you're counting. So you
Yeah.
don't then take that away from that because they're different things.
Things. Different things. Yeah.
And these are pies, 36 of them.
Yeah.
Okay?
Yeah.
That makes
Brilliant.
sense.
Okay.
Now,
Yeah,
hey,
that's great.
if it was a calculator paper,
Yeah.
you could then work that out to be a number by doing on your calculator 144 minus 36 times pi. Now, do you know the value of pi? 3.142.
Okay.
Did you know that?
No, I'll write that down. The value of pi is
142.
3.42. Okay.
And if you've ever seen The Life of Pi, the movie,
Yeah. Yes.
so loads of decimal places, doesn't he? Remember in the film?
Yeah.
That's why they called him pi, wasn't it?
3.1. Okay.
The value of pi to a very long string of decimal places.
Yeah.
Anyway,
Brilliant.
fine.
Brilliant.
That's the answer. Now, so that's about 3, isn't it? Then.
Yeah. Yeah.
So that's actually 36 times about 3, isn't it?
Yeah.
So that's about 108,
Yes.
roughly speaking.
Yeah.
So it'd be 144 take away about 108.
108.
So it's about
Yeah.
36 then, isn't it?
Okay.
Yeah. If you wanted to get a number, but you don't want that in this question.
No, it's not asking
Let's
that.
give it in terms of pi, and that's the correct answer there.
Okay. That's great. Thank you, sir.